Okay, so we're not going to do any problem solving here. We're just going to focus on things that we've covered already and to kind of remind ourselves appropriate times for using them, and also talk about maybe some hints or things to look for when you're trying to decide what to use. So we'll start with kinematics. So kinematics is like the 5 equations like delta x equal v naught t plus 1/2 at squared, etc. And we kind of use these when we have 1D motion, so motion in a straight line, or like projectiles, and we're given information about maybe acceleration or displacement, etc. And one of the keys is that acceleration needs to be constant for this to work. So next, forces and Newton's laws. So for these, this is like when we write net force equations, etc. Okay. So we do net force equations, and we'll do this often in free body diagrams when we're connecting motion and forces. And often this will be used in conjunction with something else, like in the case of work and impulse, and we'll mention that in a second. But the key here is this is when we connect forces and motion together and talk about how forces cause acceleration and how to quantify that acceleration based on the amount of force. Okay. Up next, we're going to talk about work. Okay. And so the key here is work is when there's a change in energy. Okay, and there's one key here. For work, the thing that we really need to pay attention to is this. Let me clean this up a little bit. Our clues for when to use work is when we have a force and a displacement. Okay? If you know that there's a force acting over a distance, that's a clue that we need to use work. So if it says like a block slides to a stop over a course of 2 meters, it's brought to a stop by friction, that's a big clue that you need to use work. Okay? And that's really what you need to be looking for. So anytime you see force and distance, work is what you need to be thinking about. Okay, that should be like a trigger for work. Okay, so think, whenever you see force and displacement, think work. Energy can be used in a lot of situations. This is kind of frees us from thinking about direction. And energy allows us to do a lot of calculations like that we did with kinematics or with forces, and simplify them in scenarios where direction isn't necessarily relevant. And it allows us to look at kind of energy transfers, so like situations where we're transferring from potential energy to kinetic energy, or maybe energy from a spring, something like that. And so energy conservation can be useful in a lot of situations. There isn't necessarily one particular indicator, except it's helpful in a lot of situations where other things don't make sense. So we could have a problem that involves a lot of stuff going on, probably like a two-dimensional problem, where maybe something's like sliding along and then it's like gaining height or something. And so a question like this, kinematics wouldn't make sense because we don't have constant acceleration and it's not one-dimensional. And so energy would make sense for a question like this, because that allows us to kind of ignore some of those things and just focus on energy transfer. Okay. Next, impulse. The clue there is it's a change in momentum. And the key here is we're using impulse when we know that, or when there's a force acting over some amount of time. Okay, so impulse is important when we have a combination of force and time. So force and displacement, work, force and time, impulse. And this is the key, okay? Displacement, work, time, impulse. So if you're in a problem-solving situation and you see something connecting forces and time, you should be thinking impulse. If you're seeing something connecting forces and displacement, you need to be thinking work. Okay? And then finally, momentum is for collisions. Anytime you have a collision, that's where you should think momentum. That's really where momentum is most relevant. You might see some situations where momentum comes up that's not a collision. So, well, explosions, where things are pushing apart from each other, that momentum is used. And then also, like, in the case of, like, you'll see it sometimes if you have, like, a truck that's rolling along and water's dripping out of the back. And so it's, like, losing mass, and so technically it'd be, like, gaining velocity. You could see that in a momentum situation, but generally momentum, we're really going to use it to focus on collisions. Okay? And this hopefully, I mean, this is pretty much an overview of when you should be using these things. And if you have a scenario that doesn't really fit into any of these, then you have to kind of decide which one it fits most closely to. And oftentimes in those situations, energy might be the way to go. So anyway, I hope this was helpful. Please let me know if you have any questions, and we'll discuss this further in class.